I mean, I'm a class teacher, so I'm not getting the whole half of this.
You're touching that.
Do you like it?
Cool.
Yeah, I hope so. You are now.
She wasn't licking it though.
They've shared.
Veterans.
Have you? Wowzers. Toothbrushes.
Yeah,
well,
well,
no,
it says
no.
12 and 9, but I think it's time at least for me to.
She was a woman.
That's good.
Alright, we'll go ahead and get started. So welcome everyone to the Tools and Technology Seminar Series. I do see a few new faces, so if you haven't been here before, this is a weekly seminar series every Thursday at this time. It's really just a venue to talk about tools, technologies, methodologies, either in development, maybe recently developed, new versions, or even just tools that have been around for a while but maybe being used in novel or interesting ways. Of course, we won't be meeting next week because it's Thanksgiving, but we will pick up again the week after. So I'm pleased to present our speaker today. We have Becky Reamy from the Kretzler Lab in Nephrology, and she's going to talk to us about Nephroseq 5.
All right, welcome everybody. I'm going to spend a little bit of time talking about Nephroseq version 4, and then I'm going to talk about Nephroseq version 5. I'm also going to take a little bit of time to talk about like how we built it. So it's more than just like the tools and tech, but it's also the process and procedures that we use. And so I wanted to take a little bit of time just kind of talking about our Agile software development processes. I'm not sure how many people are familiar with that, so just going to go over that. And feel free, if you have any questions, just raise your hand, interrupt me, that's fine. So I don't want to just be talking to you guys. I want you guys to get as much out of this as possible. Just a little bit about me. My name is Becky Reamy. I've been a software engineer for about 20 years now. I am lead software engineer in the Kretzler Lab. And there's my unique ID, so if you wanted to email me, email me. So first of all, how many people here have heard of Nephroseq? Okay, I see a lot of hands. Good. So it's a web application that allows our users to visualize gene expression data in data sets across multiple data sets. So a lot of times you'll have like one data set and you can look at it and that's interesting, but it's really nice to be able to actually compare that to other people who have done similar studies and say, is this gene upregulated in this other disease, or is it upregulated in their data set as well, to make sure that there's not, you know, something weird going on with yours. You can actually see that it's maybe something real. Nephroseq version 4 was originally written for cancer researchers. And we're gonna, in a minute, we're gonna go out to nephroseq.org and kind of take a look at it. But it was written in around 2008 is when we started at Compendia Bioscience, and that was actually a spin out of from U of M. It was written in Java 6. It has since been ported to Java 7, but it was basically just recompiled in Java 7. We didn't do a whole lot to really make use of any of the new features of the language. It uses a lot of outdated technologies, and so it's getting harder and harder to maintain. It's very powerful. There's a lot of stuff in there, but it's also very confusing for our users. And it's more complex than what we actually needed, especially in nephrology. So I'm going to take a few minutes and I'm going to show you Nephroseq 4. I'm going to take a little bit of time and look at Nephroseq 5 and how they're different. So this is Nephroseq 4. This is the landing page that you come to after you log in. And you can see there's a whole bunch of filters over here that you can apply. There's a lot of different types of filters that you can apply. and you can search for things. So let's go ahead and just search for EGF. And the first thing you get is you get this like big summary table that kind of shows like how this might be interesting across the data that we have in here. But I'm going to just kind of, sorry, whoa. I'm going to jump over to the data set view and show you we've got this like nice list of data sets here and analyses that we ran on the data set. So we have basically a set of analyses that we know that we want to try and run on a given set of data, and we try to run those same analyses on all of the data if we have that data available. So we might do a gender analysis if we know the gender of the samples. We'll do things like tissue type analyses. So this tissue type versus all the others, that sort of thing. And so there's a lot of stuff here. You know, this is broken down by data set. So your most important analysis is at the top, but this next one down, keep scrolling on me. This next one down may not be the next most interesting analysis. It may actually be down the list a little bit because we've got it broken down by data set in this list selector. But you can kind of see how important they are by these little boxes. Maybe not immediately obvious to somebody who's new to the application, but that is how it works. And then we've got the actual visualization over here, so you can see, excuse me, you can see the bar chart here. You can flip over, and you can see the box plot here, showing how those samples actually compare to one another. So we rethought, did a lot of thinking about how we actually want to present this data differently in Nephroseq 5. So I'm going to go ahead and, oops, wow. Oh, I don't know what's going on here.
That's a great move.
Don't know why it's doing that.
Sorry, I need to do this. Keep scrolling on me.
It's weird.
Okay, so this is I'm gonna make this full screen if I can. All right, so this is Nephroseq 5. So you can see we started off on a little bit simpler page. We have the same kind of summary information here that we saw on that landing page in Nephroseq 4, and we tell you, look, search for a gene. So you just type in your gene. We're gonna do EGF here as well. And this is going to take a minute just because it's got to go and get all the data. There's a lot of data there to get. And you can see which gene you searched for over here. We can apply filters to like narrow down our results. And we can also change our thresholds here so that if we really want something that's more significant than a p-value of 0.05, we can change that here. But we get a lot of really nice results here, and we get scatter plots here. We get correlations. Which we didn't have in Nephroseq 4. So we had some kind of faked out correlations, but not real correlations. So we actually have correlations in Nephroseq 4, which is nice. And if you wanted to see this a little bit bigger, you can click on it and you can actually bring it up and zoom in and see it a little bit more. You can hover over each of the dots. Each one of these is a sample and see a little bit more information about it. And there's a lot of stuff still coming. We're going to have export and things like that, so you can export the data and do your own analyses on it. And you can see that this is actually ordered in kind of an importance order, so or an interesting order. So it's saying this is the thing that had the lowest p-value, so this is the most interesting result. And if you scroll over here, you can see that we've got a bunch of different data sets. It's not like broken down by data set name. It doesn't matter. That's not what's most important to the user. What's most important to the user is the thing that's the most interesting, the most relevant. And so that's how we've got things ordered in Nephroseq 5. At this point, I'm going to come back over to the slideshow and continue from here. Any questions so far? Does that all make sense? All right.
Yes.
Question?
Yeah.
When you say to use Java, do you mean the back end is Java or the front end applet is also Java?
So for Nephroseq 4, we used Java on the back end and then JSPs on the front end. For Nephroseq 5, We rewrote it, and we're using React and Redux on our front end and Java 8 in the back end. We're using Bootstrap on the front end for helping with our layout and that sort of thing, so that we get a very consistent visual appearance to everything. We're using D3 and a couple of libraries built on D3 for drawing our visualizations, our scatter plots, and our box plots. Excuse me. It's a Java 8 background. We're using Spring Boot, which just like comes with a lot of stuff already built into it, and it makes it really easy to run it as a service on our servers, so we can have the backend just running as a service, just really easy without having a lot of extra work for us. Hibernate for talking to the database, and we updated and simplified our data model. In Nephroseq 4, we had a MySQL database, as well as a bunch of flat files that there were binary flat files that were kind of proprietary format. They were designed to help make like the workflows that we had envisioned work very easily, but there were a lot of work to actually implement and create and maintain. And so instead, we just put it all into a database, and it's actually working pretty well. You can see it wasn't. I mean, we've got a little bit of performance, improvements that we can make, but it's not like slow. So that was really nice, and it makes it a lot easier for us to actually be able to query the data and use different workflows than we had initially envisioned, which is really nice, and it's going to be super powerful for us in the future, because we had issues with the other data format. We couldn't do certain things because of the way the data was, or it was a lot of work for us to do that because we had to get it out and then do a lot of manipulations within the code in order to do the things that we wanted to do. So that's why we decided to go with a different data format. So here's just a quick overview of the architecture. So like I said, we've got the front end that's built in React, and then it just talks via AJAX and JSON to the back end. That's basically an API. As a separate jar file, we have all of our data models, and we did that so that when we were building the database, we could use that same code to write to the database that we use to read from the database in our application, and then just the MySQL database holds all the data. So how did we do it? We're using Agile software development methodologies. How many people are familiar with Agile? Okay, fair number of hands. And then a lot of blood, sweat, and tears. This blood, sweat, and tears? No, not that one. So I'm going to throw this up here. I'm going to give you a few minutes to read this. There's a lot of words here. It's really dense. I'm going to talk about it. So you don't have to understand it, but take a minute and read it, and then we'll talk about it a little bit and break it down. Everyone good? All right. So there are a lot of words there, and it's a little hard to understand with all those words jammed together. So we're going to break it down and pick some of the key points out. So the first one is collaborative effort of cross-functional self-organizing teams. Excuse me. And what that means is our team is not just software developers. It's not just software developers and project management. We have software developers. We have project management. We have people who wear a QA hat. And we have user experience designers, and we have our data manager as well. And we all work together to build this product. We also bring in our customers. We talk to the people that we're going to build this for and say, hey, here's a new design. Here's what we want. Here's the problem that we know that you have. Here's a design. Let's go look at this and see if this actually works for you, and if it actually solves your problem, gives you the results that you expect. Adaptive planning, which is a little bit different than what you would see in like waterfall. In waterfall, you're saying, all right, here's the thing that we need to build, and we have to have it done by this date. Go. And if you don't get it done in that time, well, then you just have to put more hours in. With adaptive planning, we're like, all right, here's some work that we need to do. How long is it going to take? We give an estimate. And then if it goes longer than that, then we say, We take a step back and say, all right, we were hoping to release by this date. Can we move that date? If we can't move that date, can we reduce the scope? And it kind of increases the communication like throughout the team. So everybody knows where we are, and we can actually plan more effectively and get a successful release rather than like everybody killing themselves to try and get what was promised at the beginning done. Early delivery. So that one's really important. We want to deliver this thing as early as possible, something valuable as early as possible to our customers so they can look at it and give us feedback and say, yes, you hit the mark. That's exactly what we wanted. Or that's almost there. Let's make this little change, and that will make it make a lot more sense. That'll make it a lot more useful for us. And that's early delivery in the actual software product, but it's also early delivery in terms of like our user experience designer. He might have something that's mocked up and not really like a tool, but he can go out and say, hey, here's what we're thinking, and show it to somebody and say, and have them give a little bit of feedback so we can make adjustments and make it more useful for our customers. Evolutionary development. So in a lot of development shops, somebody says, okay, this is what this thing is going to look like, and you've got the architect figure out exactly where all the pieces are and how they're going to work together, and then they say, okay, go build it. And then the developers sit there and try and build it, and then the real world comes into play, and it doesn't quite work the way the architect envisioned it. We try not to do that. We take a little piece at a time and build a little bit at a time, and we might have like an overall idea of how we want this thing to look, but it's going to change when the rubber meets the road, right? We all know that that's going to happen. We all know that if somebody comes up with this design in a vacuum and hands it over, it's probably not going to work. So we take that into account in our process. We say, all right, and if we start working on something and go down this path, and then we have this other thing that's not going to work, then we try to adjust it and bring it back so that it's something that's still easy to maintain and still easy to do. And, we've changed our design, and that's fine. That's why it's evolutionary. And continuous improvement is a huge part of what we do, and that's across everything, not just our code, but also our process. So every week when we finish an iteration, we get together and we talk about what went well and what didn't go well. And we try and figure out what we can change to make things go well or make things go better. And sometimes that's, hey, we're having a lot of bugs. What's going on? Oh, well, this piece of the code is really tricky. So, okay, let's take some time and look at that piece of code and see if we can figure out a different way to do that. Or, gosh, we keep getting bit by this one piece of our process. This is a pain in our butts. How can we make this better? Hey, maybe if we do this other step first. Maybe if we, throw it in front of QA before we actually are like done, so they can look at it and go, yeah, that's what we meant. That's exactly what it should be. Or, no, you missed it. This isn't quite right. This isn't behaving the way we expect it to. That's what we do. We try to make those changes. And every week we try and look back and go, what worked, what didn't work, instead of like at the end of the project, where a lot of places will do end of the project, you'll do, you'll look back at the whole project and figure out what went well and what didn't. At that point, it's too late. The project's done, and you're probably not going to take those learnings on to your next project. You might, but it's more likely that you're going to take little changes, as you're moving along, and you'll keep making your process better and make it work for you and your team. Because what works for one team might not work for another. So, like I said, we have a cross-functional team. Zach and I are software developers. Chris is a part-time software developer for us. We've got Becky Steck here. She wears a couple of hats. She is our Scrum Master and our Product Owner and QA. Rachel here is our Data Manager. And then Michael is our User Experience Designer and QA. So a lot of us wear multiple hats, but we all work together and we all talk to one another all the time. So we sit next to one another and we have a lot of meetings together and talk to one another about how we're going to do these things and make sure that we all understand what needs to be done. said we have weekly iterations. So every week we Becky lays out, this is the things that I want you guys to work on this week. And we, as developers that are actually going to do the cards, give estimates on those things. We say, yeah, I think that's going to take me 8 hours. So we put that in the sprint. I think that's going to take me 2 days. And if it's going to take like more than a week, I'm like, okay, that's really big. How can we make this smaller? Because if we can make it smaller, that means we understand it better. And if we understand it better, then we're more likely to get it right. So we try to make our pieces of work really small as we can, while still delivering value.
Can you also just explain time boxing right now as a way to avoid big stories?
So sometimes we have something that we can't give a good estimate on because we don't understand it well enough, or we think it's going to be really complex. So what we might do is we might write a story that's a time-boxed story. And what that means is we say, all right, I think I can learn more about this in a day, and then I'll be able to give a better estimate, and I'll be able to understand this problem better moving forward. And so we'll spend that day, and it's no more than a day, or however long we say, to just do some investigation. Maybe it's actually do some spike, which basically just means I'm going to write some code, or I'm going to go out and try and find some different libraries and try them out, and then I'm going to throw it away. And the reason for doing that is you've learned something, and then the next time you actually go to do it, you can do it better, and you understand it, and you can get a better estimate, and everybody feels better about it. As I said, we have small tasks, multiple environments. So we have 3 environments. We've got our local machines, so it's actually 4. And then we have a dev environment, which is used for us to actually throw it out into an environment that looks like production. It's on the same hardware as our production environment, but we'll just throw something out there. It's not necessarily as integrated as some of the higher environments. And then we'll do some post flights. So after we've done the card and we think it's good and ready, we'll throw it up to QA and say, hey, take a look at this. Is this what you meant? Does this work the way you expect it to? Does it look the way you expected it to? And they'll take a little bit of time and look at it and go, yeah, that looks right. Or no, this isn't quite right. It doesn't behave the way I expect it to. Or, oh, I'm getting this error, which we might not have seen on our local environments. And so then we can do some back and forth and get it working on that dev environment, and then it goes up to QA. QA is a little bit more stable. QA, everything has been integrated into our main development branch. So all of the code is integrated together with changes that somebody else may have made. And then that goes back over to QA so they can look at it and say, hey, yeah, this is all working together. You didn't break anything else. Great. And then it moves on. And then we have our production environment. So obviously that's where it goes out to our customers, right? So we don't push to production very often. We don't really have a cadence set just yet for it because we've got a lot of other things going on. But we just released, what, a month ago? About a month ago to production and to all of our customers. So we're slowly thinking about what we're going to work on the next thing, but we've got, like I said, a bunch of other things that we're doing that aren't part of Nephroseq. But we'll probably release sometime next year.
Yeah, probably March-ish.
March-ish, yeah.
Who are your customers? The Neptune and the related consortia around the world, or other kinds of?
I'll let Becky field that.
Including corporate.
But yeah, so Nephroseq, the way we have it set up, it's a free if you're an academic or nonprofit person. So when you register for Nephroseq, if you're in essence, for the most part, if your address ends in edu or org, or we can find out that your address is a different nation's academic institution, you get free access. And we have about 1,200 users like that. So it is, a lot of it is translational researchers, maybe grad students, things like that at just universities. Maybe they're not in transcriptomics, maybe they're a metabolomics person, but they needed to do a quick transcriptomics check of the genes they found in their metabolomics study, or some sort of validation. But we do also offer access to Nephroseq to pharma customers as well. We don't have many of those, but a lot of times, so Dr. Kretzler has a lot of different collaborations, and we try to work that into some of the deals with the collaborators that they can have access to Nephroseq for a time. So there are, I think, about 35 total professional, we call them users, paid users that are from 6 different institutions. So, but a lot of times it's some sort of translational researcher, but sometimes the transcriptomics people. But what we find is the transcriptomics people usually have their own data set du jour that they're working with, that they want to analyze. So a lot of times it's folks that are in a different omics space come to Nephroseq for a quick, kind of encyclopedia answer to a transcriptomics question. So maybe they validate something that they're studying in a different omics space.
Right.
Answer.
We use Jira. So Jira, we use it for keeping track of our work, for writing down like, hey, this is what we want to do, keeping our estimates, and then they have an Agile board that lets us kind of plan out our sprints. So it's really useful for us for a lot of things. Like I said, we put all of our information in there, and basically you can look back over the cards and understand like what the requirements are for the product. And then I already talked about retrospectives. Like I said, we do those at the end of every iteration, and it's really just so that we can get better. We can continue to improve our process, continue to improve our product, continue to improve ourselves.
So under the small task, go back one bit.
Yeah.
User stories.
Yeah.
Do you have a sort of file of case examples, applications from your user community?
No,
You have the data sets, but the stories and the
Well,
applications and the publications that go with them.
Well, the user stories is actually, when we write our stories, we try to write them from a user's perspective. So we have a fake user that we always use, so as Paulina, and we have like an idea of who Paulina is. So, Michael, do you want to give like a quick 30-second like who Paulina is?
Sure.
Okay.
Paulina is a representation of several different people that we went out and talked to. So we talked to researchers and biologists and bioinformaticians, and kind of took all the kind of work habits, attributes, personal attributes, and kind of created this fake person called Paulina. And she is. What's
Yeah.
that?
Synthetic person.
And yeah, I mean, she has a bio. She has a background. She has a family. She's from Germany. And we use her as like when we write the story. So as this person, I want to do X piece of research or X function, and then all the details kind of flow out of that. So when we're actually writing or developing a piece of functionality, it's her we keep in mind.
Is it
Right.
just Paulina, or do you have others?
We have others. We have
Klaus. No, not Klaus. That's
Sorry, that was
what was Arnie?
Arnie. So he's our secondary persona, and he's more of the kind of manager, kind of
Maybe in charge of a pharma or in charge of a team or of a PI type of guy who might not be doing the work himself, but he's managing that this work gets done. So the idea behind making up these synthetic people is so that, because when you are working on a new tool, you'll find that you want to do everything, and you have 1,000 good ideas about really cool places you could take this. And sometimes when you get too far down that path, you end up making 1,000 different things that no one can find useful because it's not intuitive, or it's too complex, which is a little bit of what happened with Nephroseq 4. So you start with making up a lot of these synthetic people, and then try to hone in on who you think really are the users here, so that anytime you have a decision, like an architectural decision or a workflow decision, you can ask, well, let's not ask what Becky Steck thinks this should do, but what would Paulina think this should do? Because I'm building this for Paulina. And so, for instance, within our own lab, sometimes we ask the folks in the Kretzer lab for input a lot, but then we still go through the filter of like, okay, that's what John said, but do you think this would make sense to Paulina? Because John and Paulina are very different. Right. And it helps us make sure that that we kind of have a true north for when we're developing our application, and it's easy to start going down some rabbit holes of, this would be super sweet. I just found this cool library. Wouldn't it be cool if I integrated this thing? But it was mostly just for you, for funsies. Yeah, as opposed to something that we actually think is going to give a benefit to somebody. So,
and one of the things that, like, when you have your personas, you'll have like a primary and maybe some secondaries, maybe even some tertiaries. When you're looking to say, I want to add this cool new feature, you want to make sure that hopefully it's useful for your primary persona. But if it's useful for your secondary personas, make sure it doesn't impede your primary persona. Because that's the person that is using your tool the most. That's the person that you're building this tool for. The secondary people use it some, but they're not like the real customers. They just kind of come in occasionally. So you want to make sure that you're not hurting your primary persona, and having that for that person to like think about when you're working out figuring out, okay, is this thing something that we really want to do? It really helps because you can kind of put yourself in that person's shoes and go, all right, would I understand this? Would this confuse me? Would this get in my way? Or is it, is it something that I'm just going to ignore and it'll be fine, and this other person is going to say, hey, this is really cool, and go use it? And if that's the case, then great, you can do it. But if it's going to confuse your primary person, you probably don't want to do it. Or you want to rethink it. You want to say, yeah, okay, maybe there's a different way to do this. It's not going to confuse our primary persona.
can you talk, Becky, a little bit about how we take, once we figured out Paulina, how we figure out like what feature we're going to build, and then how we turn that into cards, to these small tasks that we're calling cards. Can you give some time on that?
Sure. So I think the most recent thing is we had a couple of our people in our lab wanted a new feature. And it was something that I really briefly showed in Nephroseq 4. Remember that big grid that had a couple of cells in it that were blue and some of them were red and had some numbers in there? Well, people really kind of liked that overview of here's the data that we have in the application. But it was a very sparsely populated grid. It worked much better when it was Oncomine, it was cancer data. We had a lot more data in there, so that grid was much more populated. With nephrology data, we don't have as much. And so it's a very sparsely populated grid, and so it's maybe not quite as useful. We had some people that really liked it. So we took some time, Michael took some time and said, all right, what would be a better way to show this to our users? And so he kind of thought, like, in terms of Paulina, like, what would she want to see? How would she need to use this? Talk to some of the people that actually used that other thing and that really wanted that other grid. Said, okay, this is how they use it. All right, this is kind of the problem that they're having. This is their problem space. You need to kind of break it down into what their problem is, not just they want this grid, let's just recreate it. We try and break it down into what the actual problem is and try and figure out, all right, what is a solution for that? And so then we come up with a couple of ideas of, all right, here's like 2 or 3 different ways that we might be able to solve this problem. Then we take it back out to those people and say, okay, here's a thing that I think is going to solve your problem. How would you use this? Is this useful? Is this helping you? And I think there are better questions than that, because there's certain ways to ask those questions that can be leading, and you try not to be leading with that. I'm not a user experience designer, so I would ask leading questions.
Well, sure.
But
It's like everything. If you're re-engineering something, you break it down to the basic. Like, why am I looking at this data? What is it trying to answer? If you start with that and you ask that to a broader group of people, then you might tease out, oh, well, it was originally intended for this, but then through organic conversation, it really is useful to answer this, and that's it. It doesn't have to do any more than that. Or if you expand that functionality, then it might solve other questions at the same time.
Right. And so then we have this idea of, like, we want to build this new thing. Well, building that new thing is really big. That's going to take us more than a week. All right, how can we break this down into things that we can do and estimate and get right? So then, Michael will take a stab at it and say, okay, here's how I think we can break it down. And then he'll actually talk to the developers and say, is this too big? Does this make sense? So this morning, he actually said, all right, I think I'm going to break this down into a couple of cards. And so we had a quick conversation and said, all right, well, I think, we want to have that, like, switch. We want to have, like, a toggle on there. We can do the toggle and, like, put, like, a blank screen with a title at the top. That's an easy, small chunk of work that we can do, and it's, starting to add value. And then the next thing is we can show the table. That's valuable to the user. And then the next thing is we can actually make that table interactive. And the nice thing is, if you break it down that way, you could stop at adding the table. You don't have to add the interactivity. It's still valuable to the users. They still got that summary information. And you can say, we're getting really close to our release date. We don't have time to add this additional functionality. We can drop that. We still have something that's useful for our users. We're not in the middle of something where it's like, we can't release with it like this. We try to make sure that whatever we're building, it's releasable the way it is. So we don't end up in like this weird state where we've got something half done and, oh no, we got to figure out how to like hide it.
I'm just going to add too, obviously we have the luxury of a large team with cross-functional, right, representation, but a lot of these things you can do as one person, right? And this is one of them that you should never skimp on. You should always take this concept that you want to do and see how you can break it down into smaller pieces that you can tackle in a smaller period of time.
Yeah.
So even if you don't have some, it would be awesome if you could just bounce it to another peer and say, like, this is how I was thinking about doing this. Is this how you would attack the same problem? But even if you can't, you should still take the time to stop yourself before you're just like, I'm going to go just build that thing. And then 3 weeks later, you haven't seen daylight and you don't have that thing still. And, yeah.
Right, and you have this running list of things that you want to do, and then you forget half of them because the list keeps growing. So, yeah, that's why you break it down real small. And I mean, I worked at, before I came here, I worked at another company, and I was the only developer on this one project. And I still broke my stories down real small for myself. Wrote them as cards, put them in Jira, estimated them, did the whole thing for myself. Because that allowed me to kind of keep track of where I was and what I still needed to do. And my list of to-dos was much shorter on each card, rather than, you need to build this new piece of functionality. Here, go, right? I mean, we've all been there. We've all done that. And it's hard. And it's hard to keep all of that stuff in your head. And it's hard to write it all down on a piece of paper, because sometimes you lose that paper, or you forget to write it down, or whatever. You go home and you're working at it at home. You don't have the piece of paper. So, you lose track of stuff. So that's why we keep it. Another reason that we try and keep it small.
It's all whiteboards and Sharpies.
Another benefit is when your product manager comes and asks you, how long is this going to take, or how much effort do you think this is going to take to build it?
Right. Yeah. It's much easier to estimate a small task. So when you have a big task where it's just like, build this new view, you're like, I don't know. Right? You give a ballpark, and you hope you're close. But if you've got, create this toggle that brings up a new page and has a header on there, that's easy to estimate, right? Because it's small. It's very defined. Okay, put a new table on there that has this information in it. Again, small, well-defined, easy to estimate. So keep all of your things as small, well-defined, and easy to estimate as possible, and it's going to make your life easier when you're developing it. With that, just wanted to give thanks to the Kretzer Lab, Zach, Becky, Michael, Chris, Rachel, Matthias, and the entire lab. Anyone have any other questions?
Yes.
Start here.
Sure. So, say you have a lab that's been working on some project for a long time. Do you have any tips for getting a group of people who should be driving this kind of? If you want to adopt a more agile approach, who should be driving the kind of team to kind of move, convincing and kind of teaching people how to work in a more agile software development environment? Because I once reached move from, say, even just moving from some version of Git, just kind of getting people to think in that way was a bit of a struggle.
Sure.
And so moving to a much more integrative workflow, bringing all people together, do you have any tips for kind of getting from a less organized kind of group to a more organized agile workflow?
Yeah, I think anybody can drive that, including developers. I have tried to drive that in the past. The one thing you do need to do is you need to make sure that management is buying in on it, because without management buy-in, it's just not going to work. Because they're not going to work with you and say, oh, we're going to make sure that we adjust our scope because you guys aren't meeting, what we want. So you need to make sure that you have buy-in from everybody. But you can start off like very simply by saying, hey, let's break these down into smaller tasks. Let's estimate these smaller tasks and kind of start slowly there. If you wanted to try and like slowly introduce it, you could start with like a Kanban board. Instead of like doing full out sprints, you could do Kanban, and then you have the small tasks and you've got it, and then kind of like slowly start introducing these things. I would highly recommend like starting introducing retrospectives right away, and try and say like every week or so we're going to meet and we're going to talk about what worked, what didn't work, and try and improve our process. So you can kind of slowly introduce it. That sometimes works a little bit better, especially when it's brand new to the entire team, because that way it's like kind of small bite-sized chunks like you do with your work. You want to try and do it with introducing a new process. You could try and do it all at once, and maybe that'll work, but it might be hard, and I mean it may still be hard to do it a little bit at a time.
I would add, go ahead, you should add first.
Does this process work for everyone?
Time out. I want to add to this just a quick. So to get by, what you should also look at is what problem do you think is the problem you're trying to solve with it, to kind of figure out both what to start with and what to get buy-in with first, right? So if your problem is that you keep missing your deadlines, then maybe the first thing you start with is the small chunks or whatever. If the problem is like people are catty at each other because they keep thinking, well, so-and-so, screwed this up or something, maybe your retrospective is what you start, because what you want to start with is something that people will feel the value in. Yes. And then you can build from that. So if people are feeling like they don't know what's going on, then maybe putting it all on a Kanban board is where you start, because then they can see that. But you want to get that adoption, especially for management, you need to make them feel like they're getting something out of this. And so you kind of have to figure out what hurts the most and maybe start with that one. Sorry, go ahead. Will this work for everyone?
I think it does work for everyone, but I think it's going to work differently for everybody. So that's the one thing, like, it's not like here is the process and you must follow this process. There's a process out there, and you can go out and you can read a whole lot about it. And to start off, I would say let's follow the process that you see online, but then make it work for you. So you might have to make changes to that process. Some parts may be valuable, some parts may not be so valuable for you or your team. And so kind of, feel that out and try little experiments. That's the nice thing about doing the weekly iterations, is you can try an experiment and you can find out if it worked very quickly or not. So fail fast, right? Try it out. Did it work? Did it not work? Okay, if it didn't work, okay, how can we adjust it to make it work a little bit better and a little bit better and a little bit better?
Maybe iterations. Maybe you need to go 2 weeks instead of 1 week, because I only work on this project so many times.
Right.
It's an option that you can change.
Yep.
So I'll also point out that a lot of these practices and processes require, encourage, enforce collaboration.
Yes.
And if that's what you want, then you can adapt some of these processes. There are cultures that don't fully embrace that idea. Mm-hmm. And these practices and processes will either not work at all or will not realize the benefit in those circumstances. There's nothing wrong with those organizations. There's a lot of really powerful individual contributors that have changed very important things. But I would actually answer that question a little bit differently. This process probably doesn't work for all individuals, and it probably doesn't work for all cultures. But having done this for 20 years, I will say frankly, I have never been good at telling who it works for. And with that in mind, I would say try it. And for the people that it works for, do more of that.
Right. I think we had another question over here. Yes.
I'm just curious about the data on the back end of this. Is it mostly static, or does it change often? If it changes, how do you manage that? And how do you manage that and the development of the front end and how the two things interact and all that sort of stuff?
Right. So thankfully right now the data do not change a lot. You know, I don't know how often we add new data. I know we're going to be adding some new data coming like in March.
Right. So, you know, the sexy world of chronic kidney disease doesn't have as many publications with new data sets being generated, you know, at the pace that, for instance, wheat cancer was, where we worked at when we developed Oncomine, which this is based on. So a new gene expression data sets coming in, maybe a good one once a quarter or so. So then we don't necessarily release them every quarter. We might wait and accrue 6 at a time or something. We honestly haven't added any new data sets since January of 2016. Though we're now working on some RNA-seq data sets, because we're just catching up in kidney disease and doing RNA-seq now. So, or publishing on it now, I should say. But then there's other types of data that we need to look at, like for instance, our gene, the reference genome that we're using, that we're mapping all of our data sets to. That we kind of have every once in a while. Maybe every few years is all we're doing, because. It's a heavy lift for us, and it's also difficult for our users to keep changing their results on them a little bit. Because remember, Paulina isn't probably a bioinformatics guru who lives and breathes ref gene, right? Yeah, she is not that person. So when we think about Paulina, we don't want to just always have the latest and greatest for her. We would much rather have her have something stable every once in a while. So our data isn't churning a lot, but we do have processes for exactly when we have to add new data or change the data. We do a lot of these similar steps. We just also bring in the data management team of one. But it still goes through the same questions of like, how can we break this into smaller pieces? How are we going to check this? Let's put it on QA and do some work on it. Before we do those, before we release it to the public, we check it internally first. We have a bunch of our own data QC checks to make sure there's integrity. That, for instance, before a gene expression data set gets actually loaded in and made public, we make sure that we can kind of replicate the results of the paper, the gene expression results in the associated publication. We're going to change it a little because we normalize the data a little differently than them, but certainly it shouldn't be going in the opposite direction, right? There's a couple of things we can do. So we have a variety of quality control steps in a process that we've developed over the years for the data sets as they come in, but it's not, and those processes are based on data that was changing weekly, but they still happen to work for these at a slower pace.
And we do normalize the data. So, you might get gene expression data from this person and gene expression data from that person, and it might be in a slightly different format, right? So we normalize that data. We use a controlled vocabulary on it. So we say, we always call, one thing, that thing, instead of like, let's say in cancer, you'd have a breast cancer and a breast carcinoma, right? We always call it the same thing. We would always call it like a breast cancer, right? So we try to make sure that it's really easy for our users to understand, and all of the data is going into like one database. It's all normalized, so we don't have, we've got a lot of tools that help us like do that, data manipulation to get it all into a very standard format for us. So we're not having to worry about like, how do I jam this thing in here? This is in a different format, because we do that manipulation.
It doesn't upend your front end development much, because we put it into this. We change them all into square pegs.
Have you connected Nephroseq with Transmart, which I know you guys use, or with Cytoscape?
Right. No. No. It's the short answer. We also support Transmart instances, but it's for a different audience. So the Transmart instances we support are for folks that want to analyze their consortium data set. So, right, like the Neptune data set, for instance, all the Neptune people can get at it, but it's not widely shareable yet for everyone else. So the work they can do, the Neptune folks want to look at just their Neptune data set, so they don't use Nephroseq very often. And though the Nephroseq people would love to get Neptune in it, at the Neptune data set into Nephroseq, we can't yet until enough time goes by and publications are published and that kind of stuff. So they're not. But I will say, Gil, that many things are inspired by the other. So when we do Nephroseq development, for instance, the way we do our gene synonym searches was we kind of like how Transmart does it, so let's use that same features. And similarly, we sometimes do our own Transmart development, and we'll say, we really don't like how Transmart does this, but we figured it out over here for Nephroseq, so let's let's jailbreak Transmart and make our own improvement to that. So even though we haven't integrated the two apps, they're both in our minds at all times. So they're integrated in here.
That's good.
So
Do you maintain archived versions of different data releases? So
Yes.
someone can reproduce?
Yeah, we do. We've got them backed up on a server.
right. So a user, Paulina can't go and see. Let me look at this thing from 2 years ago. But if she wrote the support desk, which is me also, we could get that for her. Yeah.
An extra degree of difficulty that hasn't been mentioned is that right now we're supporting both Nephroseq 4 and Nephroseq 5. And Nephroseq 4 and Nephroseq 5 have identical data. And so we are, for the moment, constrained about how we can move Nephroseq 5 because we don't want to break that link just yet. But there will come a time when we sunset Nephroseq 4, and then we'll have more latitude about data versioning, data privileges to expose certain data sets to certain subgroups.
Yeah. Good point.
Yeah. Very good.
Any other questions? All right. Thank you.
Thank you.